Today we're on page 12 of the AP Chemistry Chapter 15 packet, and we're simply going to review the four zones of a titration of a weak acid, HA, with a strong base, NaOH. Recall that in the beginning we're going to have just the weak acid, HA, in the flask. So you can see a little diagram here that you only have HA in the flask. If you have a weak acid, how do you handle that? You do ice right here, and then Ka. And that's going to help you get the pH of this initial point right here. Then after that, we're moving into what we're going to call the buffer zone. In the buffer zone right here, you're going to have both the acid and the base, the weak acid and its conjugate base. So I'm going to call this the buffer zone because you're going to have both the weak acid and its conjugate base. A special part of the buffer zone is going to be the halfway point. At the halfway point, which is right here, this is halfway to the equivalence point. When you're at the halfway point, you know what's special is that the H is going to equal the Ka, and therefore the pH equals the pKa. That's only at the halfway point. If you're any other place in the buffer zone, which we didn't really do much in the homework on this, but if you ever had to, one of the OH is always going to run out in the buffer zone. So if it's not the halfway point, but you're still in the buffer zone, just recall in your stoichiomoles, you're going to have weak acid and weak base both, so you're going to just use the buffer shortcut in zone 2. Zone 3 is the actual equivalence point. So remember what happens in your stoichiomoles. You're going to have stoichiomoles for every zone except for zone 1, because zone 1 is the weak acid by itself, then every zone after that has stoichiomoles. In this stoichiomoles, you have a buffer. In this stoichiomoles, these both ran out. So you only have the A minus. You have to ask yourself, what's A minus? It's a weak base. A weak base has to have ice and Kb. So this is going to have ice. Well, sorry, that's ICF. You're going to have ice and Kb. Okay? And remember that that's in molarity. So you have to get moles over liters for that. So you're only going to have the weak base by itself at the equivalence point, which is right here. Then, past the equivalence point, you're in zone 4. So when you did your stoichiomoles one more time, your stoichiomoles, you're always going to have leftovers of the OH minus, which is a strong base. So therefore, when you have a strong and a weak, you only care about the strong, and you just do molarity equals moles over liters, and that's the total volume. So even though you have both the weak and the strong, you're going to have just care about the strong. Okay, so all these pictures were to help you out. You'll notice that in zone 3, we just had the A minus there at the equivalence point, and then in zone 1, we only had the weak acid, and in zone 2, we had both the weak acid and its conjugate base, which was a buffer. Now we're going to discuss the four zones of a titration of a weak base with a strong acid, which is page 13 of the AP Chemistry Chapter 15 packet. We're going to start with zone 1, and zone 1 is where you only have your weak base. So you can see that you're going to start with a pH that is a little bit higher than 7. And if we take a look at the calculations, you'll recognize that you only have the ammonia in the flask. So if you only have the ammonia in the flask, you have a weak base. How do you handle a weak base? You do ice and Kb. And that's going to be the initial of the titration. Now, as soon as you add any drops of H plus into the flask, you're going to have a reaction, so stoichiomoles, and it's going to turn into a buffer because the H plus will run out, and you're going to have a bunch of base and a bunch of acid from the weak base conjugate acid. So that's a buffer. So any point in the buffer zone you could find the pH, but the special case is the halfway point where you're going to have the OH minus equals the Kb or the POH equals the pKb. So once you knew your equivalence point, you could have figured that out in the beginning. Your halfway point is halfway there. So I'm going to write the word buffer zone here just to remind you that this is a buffer. And when you are in the buffer zone, you will be able to use the buffer shortcut. But you don't even need that when you're doing the halfway point. Okay, so during this stage, lastly, one more time, you're going to have your weak acid, your weak acid and your conjugate base, and that's going to form a buffer. Now that's going to bring you all the way to the equivalence point. Once you're at the equivalence point, you matched exactly your moles of weak base and your moles of acid you're using to titrate, so these both run out, and now you only have at the end the weak acid. So what is that, a weak acid? What do? You do ice and Ka. And when you do that, you're going to notice that the equivalence point has a pH that is lower than 7 because you have a weak acid by itself. Don't forget the trick here that you have to use molarity. So this is molarity, which is the moles of the acid here divided by the total volume of both of these that you used. Okay, so the moles over total volume gives you molarity, ice, and Ka. Yeah, and the problem with this is that you might not know the Ka. You might have to get it from the Kb. So let me just write that here real quick. Kw over Kb equals Ka. So be careful about that. Okay, now let's go to zone 4. In zone 4, you've added excess of the strong acid. So now when you do your stoichiometric moles again, you're going to have excess of this, and that is a strong acid and a weak acid. And when you have both a strong acid and a weak acid, you only care about the strong, so you're going to put that over here, over the total volume, and now you have both the strong acid and the weak, and you only care about the strong. And I believe I forgot to emphasize here at the equivalence point that you have only the weak acid in the flask, and that's why you have to do ice and Ka.